All right, so let's go through this question. It basically is asking you if I have the expression a times cosh of x divided by a, as a changes, what kind of pattern do you see in the graph? Easy, we're just going to graph it and see what happens. Okay, so first I am going to simply start with cosh. Cosh of x is a graph that looks like this. We know that it's an even function. It's a mixture of e to the x and e to the negative x, and it's split it in half. So that's why we know that it's a very nice curve that kind of looks like a parabola, and it's also usually modeled as things like wires hanging. Okay, let's see what happens when y is equal to 2 cosh of x divided by 2. As you can see, the pattern is that now the height is, instead of at 1, it's now starting at 2. It's being stretched out horizontally a little bit more. Let's see what happens if it's equal to 5. Y equals to 5 cosh of x over 5. You can see that now the height is a little bit higher. It starts at 5. It's being stretched out even farther. So long story short, this pattern continues. If y equals to a cosh of x over a, depending on the value of a, you're going to be able to see what's going to happen. So if it goes like this, when a is a fraction, it becomes very small. When a is a large number, it just gets taller and taller and it gets stretched out horizontally. So I want you to pay attention to my cursor. If you imagine that this is a point that I can pull to the left and to the right, that's basically what happens with wires. If you pull the wire sideways, far apart from the center, the graph is going to be stretched out even more like this. And the very bottom part of the wire starts getting taller and taller, right? So this is one of the reasons why this graph is very useful for representing how wires behave, okay? And that answers the question of how a cosh x divided by a behaves.